Create APCalculus Notes 8.4, Video 2. We are going to find equations of inverse functions from exponential to logarithmic. And we are also going to look at a table and see if we can make some conclusions about the domain and range of logarithmic functions. So looking at this first problem, we want to interchange x and y. And we want to get y by itself, ultimately. To do that, we want to get the base and the exponent by itself. So I'm going to add 3 to both sides. This gives me the equation in exponential form, which allows me to then change it to log form. Change this to log form, it would be log base 2 of the argument equals the exponent. In order to get y by itself, I'm going to subtract 3 from both sides. Then I'm going to multiply every term by -1. There are 3 terms, 1, 2, 3. And then I'm going to put it in inverse notation, which would be f inverse of x is equal to 3 minus log base 2 of x plus 3. Let's do another. Number 2, I'm supposed to find the inverse. I'm going to interchange x and y. And we want to get the base and exponent by itself. I'm going to subtract 3 from both sides. This is currently in exponential form. I want to change it to log form. This would be log base e, which is common log, of the argument x minus 3 equals the exponent. To get y by itself, I'm going to subtract 2 from both sides. And instead of writing a y, I'm going to use the inverse notation. I intentionally put the constant on the left in both of these cases. You don't have to, but it just makes it clear that that's not part of the argument. So I typically write that way. And number 3, you know what? I think that, it's weird. I changed this at one point. Somehow, change didn't carry over. I apologize. I wanted to call this g of x, which would make this g inverse. And I wanted to call this one h of x. And that's going to change this down here also, for this to be g of x and this to be h of x. It's weird because the paper that's in front of me has this change, but I must have grabbed the wrong file from my computer. Find the inverse, interchange x and y. And then we are trying to get y by itself. I'm going to subtract 1 from both sides. I'm going to multiply each term by -1. I don't want to distribute that because it makes graphing and analyzing this easier. That's in exponential form. To get her in log form, it's going to be log base 3 of the argument negative times x minus 1 equals the exponent of y minus 2. If I add 2 to both sides, I'm going to end up with h inverse is log base 3 of a negative times x minus 1 and then a plus 2. I end up putting the constant on the right this time just because I forgot to not do it. So that's how we find the inverses, and then those same functions are down here. So we are supposed to fill out this table. The directions I deleted on accident. Complete the table below of information about the exponential functions and their inverse logarithmic functions. So a couple things here before we get into finishing the table. This graph, is it above or below the horizontal asymptote? Well, there's no vertical reflection, so this is going to be above the horizontal asymptote. G of x has no vertical reflection. It's also going to be above the horizontal asymptote. H of x has a vertical reflection because this negative are multiplying on the outside. It's going to be below the horizontal asymptote. That's all relevant for domain, range, and such. What's the domain, range, and horizontal asymptote of the function? And let's get rid of f of x here because, man, I can't believe that I changed this and it didn't. Sorry, I'm dwelling on my mistake. So let's find the domain, range, horizontal asymptote of the function. We have f, g, and h. So for f of x, it's an exponential function. The domain is going to always be negative infinity to infinity. Every exponential function, that's true. For the range, you start at the horizontal asymptote, and you either go up or down forever. Since we said this is above the horizontal asymptote, we're going to start at the horizontal asymptote and we're going to go up forever, which we should probably figure out where's the horizontal asymptote. The horizontal asymptote is whatever. It's normally at 0. This has been translated down 3, so it's at -3, which means the range is going to go from -3 to infinity, non-inclusive. For g of x, since there's a constant of 3, there's a horizontal asymptote at y equals 3, which means the range is going to go from 3 to infinity, because it says it's above the horizontal asymptote. For h of x, it has a horizontal asymptote at y equals 1, because this constant is a +1. Since this is below the horizontal asymptote, the range is going to go from the horizontal asymptote below it. So it's going to go from -infinity to 1. Now, what's the domain, range, and vertical asymptote of the inverse? Well, this is pretty simple. If there was a horizontal asymptote at these places, whoops. First of all, that is going to change to a vertical asymptote. And instead of it being y equals the number, it's going to be x equals the number. Remember, to find an inverse, you interchange x and y. Something horizontal becomes vertical. A y equals -3 becomes an x equals -3. The range for every, the range for every logarithmic function is -infinity to infinity. Now that's easy to know because, once again, the domain for a function becomes the range for the inverse. So to find the range of this inverse, we just look at the domain of the original function, so it's going to be from -3 to infinity. The domain for g of x is going to be from 3 to infinity. The domain for h of x is going to be from -infinity to 1. What's the inverse equation of each of these functions? Well, Sorry, I got distracted again because my table has an extra column in it that I don't want in it, but I don't know how I screwed that up. Equation of the inverse function. We found those up here. So we already did the work. We're not going to do it again. So here's F inverse. And here is G inverse. And here is H inverse. All from the top. That's why we did it. Well, it's one of the reasons that we did it, so we could put it into this table. Now, some things that I want to point out. We said that the function f of x was above the horizontal asymptote. So above means positive in the y direction. That means the inverse is going to be positive in the x direction. This is going to be to the right of the vertical asymptote. G of x was above the horizontal asymptote. That means the inverse is going to be to the right of the vertical asymptote. H of x was below the horizontal asymptote. That means H inverse is going to be to the left of the vertical asymptote. I do not want to fill out this column. And instead of saying F inverse, I'd rather that just say inverse right here. My apologies. Set the argument of the inverse greater than 0 and solve for x. And let's see if we find something familiar when we do this. So if I take the argument and I set it greater than 0 and I solve it, what's going to happen? Well, what's going to happen is this is the domain. Not a coincidence. If we do that for this next one, we got x minus 3 is greater than 0, and we solve it. We get x is bigger than 3. It's not a coincidence. The domain is 3 to infinity. If we do this for this last one, we have a negative x minus 1 greater than 0. If we were to multiply both sides by negative 1, that changes the inequality sign around. Then if we add 1 to both sides, we get x is less than 1, which is the domain negative infinity to 1. Sorry about the table being messed up. Hopefully your copy isn't. Hopefully not other things aren't messed up in here. So that concludes this video. And that is us just reviewing the fact that the domain of a function is going to be the range of the inverse. A horizontal asymptote of y equals negative 3 becomes a vertical asymptote of x equals negative 3 for the inverse function. 2 more videos for this section, maybe 3, I don't know, we'll see what happens.